me? Is it clear? Is it good? Cool. Welcome. Thanks for coming to my talk. So, my name is Jezen Thomas, and I will be talking about Haskell and how it's similar to Ruby on Rails. In my day job, I do a lot of Ruby on Rails. I don't get to do a lot of Haskell, which makes me a bit sad. Is everyone here familiar with Haskell? Yeah, great. A few people. So you really like lambda calculus and monads and yeah? I don't. Sorry. I have no idea how any of that stuff works. I'm clueless. Like, Haskell is a language that a lot of people seem to think is some rite of passage to programming. Like, if you can handle Haskell, then you can handle anything. You're the master. You really know your stuff. And it's very academic to some people, and it's all about mathematics to some people. My maths qualifications, questionable. You know, high school, I was drunk and passed out on my maths exam, so I failed. But still, I build stuff that works in Haskell. And we're here because we build stuff, right? So I won't be talking about monads or about algebra or category theory, because I don't know about any of that. I won't be using the phrase, it's easier to reason about. I think if you've seen a functional programming talk before, everyone uses this phrase. It's so cliche. I think there should be like a big swear jar that anytime someone says it's easier to reason about, you just throw some money in. And maybe I should like patent that phrase, like get royalties. And here's my general disclaimer. I have no idea what I'm doing in Haskell either. But my sort of wishful thinking around that topic is that the language is so smart that it will sort of protect me from myself and from the stupid mistakes that I make. And just to be clear, just because I'm on stage and you're my audience doesn't mean I'm the expert. I'm really not a Haskell expert. If you were like expecting a Haskell expert, I'm sorry, don't be mad. I brought this dog so you wouldn't be mad. Okay, so here's the why. Here's the motivation behind why I work with Haskell when I'm not doing my day job, or you know, when I'm doing my day job, but shh, don't tell them. I started as a front-end guy. Like a lot of people, I started with like HTML and CSS and JavaScript and PHP, and I started to build things as best I could. I started to build what business people would tell me to build, and I try and fit their requirements, but I wouldn't always understand their requirements because business people and developers don't communicate so well, and we all know this. So a lot of the time, my software would have to change, and we all know that like as you change software, you have to like refactor it, and then gradually it gets broken. I'm quite pleased to be at this conference actually, because a few years ago I was at a Greg Young talk, and he said, you know, most developers, they think they're refactoring, but actually they're refactoring because they don't have like tests in place and they break the software as they change it. I got a bit tired of maintaining stuff that I'd already written. Like coding's not super fun to me. I'd rather like ship a product and make some people happy. So I got into this whole software craftsmanship thing. So, okay, if I write lots of tests and I'm really rigorous about my software development, and I really focus on naming, and I digested all these ideas from Joe Rainsberger and from Uncle Bob and from some of the people here at the conference, and I think I've watched Gary Bernhardt's Destroy All Software screencast series about 5 times. I got really into being rigorous and disciplined and taking pride in my own code. And then I went to another Greg Young talk. He's here? I don't know. I went to another Greg Young talk where he said, maybe if you didn't make things so complicated, you wouldn't have to write so many tests. And that was an eye-opener for me. Like, maybe I'm writing too many tests. So I got pretty good at writing isolated tests. But my software would still fail from time to time, because as rigorous as you can be, you can only write tests to catch the mistakes that you think you're going to make. You can't like know what you don't know to be a bit meta about it. So at some point I thought, this is not working. I would rather be lazy and let the system work for me, because the whole software craftsmanship thing, it puts the onus on the developer to be rigorous. And I don't think people are rigorous and disciplined naturally. Machines are, so we should like offload that stuff onto the machine. So that's pretty much the why. Okay, so it's about Haskell, and this is timed really nicely because Dylan's talk previous to mine was like, don't use a framework, and now I'm like, do use a framework? Haskell has, even though it's not mainstream, it has a bunch of frameworks that are mature and really stable. Some of them are analogous to frameworks that you probably have heard of in like Python or Ruby. There's one called Scotty, which is a really nerdy Star Trek reference, and that's analogous to Ruby's Sinatra. Ruby's a bit cooler, like hipster cool. This is the framework that I use. Sorry, that's the guy that wrote the framework that I use. They're not really into marketing in the Haskell world. Like, they're just happy to have their language and work with it and not be worried about selling it to people. Like, Ruby's all about sales, and Haskell, I couldn't find a logo for the framework. I just used him. So his name's Michael Snoyman. His name's not Yesod. That's the name of the framework. That's the guy. This is slightly tenuous part of the talk, because you probably can't see the figures from there, and it's not really important either. But anytime I get into a sort of war of the languages at any dinner party with other developers, or any, go to the bar with some developers, you start getting into discussions about what you should use to write software, and maybe I'll be on a team with people who are writing PHP, and someone will say, yeah, PHP sucks, let's use Ruby. And then someone says, oh, but Ruby's too slow. And then someone else says, well, it's fast enough. What does slow mean? And someone says, well, we should use JavaScript for everything because it's faster. And then I'll say, well, do you know how fast Haskell is? No. I don't think it matters, because I have two sets of figures here. On the left is like one machine, on the right is a different machine. It's an EC2 machine. And the figures are like, they vary really, really wildly. So, I mean, the point is that performance figures don't matter that much. But if you're into performance figures, if that sort of excites you, and I sort of have to use it to sell the language a bit more. At the bottom, right at the bottom, there's Django, and I think it's roughly the same speed as Ruby on Rails. These are all measured in requests per second. So it's just like someone sends a request to the server, and like a ping request, and the server pongs a response back. And on this one machine, Django and also Rails do about 2,500 requests per second. Node.js is faster, as people say it's much faster, and it is quite a bit faster. It'll do just over 11,000 requests per second. But then you look at stuff like Haskell, and it's doing just over 80,000 requests per second. And that's, I think that's a lot to do with the way the language is designed. You can't really do anything that's blocking, right? So when you're starting a Rails project, you worry about scalability, and you worry about like, oh, everything that might take some time, I have to stick it in a background job in case it like blocks. I don't want it to be slow. You have to worry about scalability. It's really comforting to me to know that with Haskell, I sort of just get that speed for free. I don't have to think about scalability so much. And with any new sort of startup project, maybe the scalability problem will be offset long enough that the business will just go bankrupt before I have to get more service. Cool. So when people are getting started with Haskell, or when they're trying to get started with web application development in Haskell, I think one of the first hurdles they experience is how do you like ship the stuff? How do you share it with people? Because there are a lot of people talking about Haskell and saying, oh, this is how you solve Fibonacci. This is how you do prime numbers. And you go, who cares? How can you make money with that? You can't. You need to like ship stuff and present a product to people so they can like pay you for it. And I've tried a bunch of solutions out there. There are many. I've tried lots of them, and none of them worked for me except for this one. This is Nix OS. It's it bills itself as a declarative, purely functional Linux distribution. And it's sort of, it's not just that, it's a bit of an ecosystem. NixOS is a Linux distribution, and Nix that goes with it is a package manager, which is purely functional. And that just means that when you install a package on your system, it doesn't overwrite anything. It installs different versions of the same dependency side by side, so you never like overwrite stuff and possibly put your system in a failed state. So it's sort of stateless as well, which means rollback's really easy, because if you make a mistake, you can just roll back. And NixOS is the same idea. You don't have your system state littered around in different files. So this like sysadmin job that some people have, I don't think you need it so much in this. I'm not a sysadmin, but I do this kind of stuff with this technology because it's really easy. You have one central config file, and then NixOS just builds the system to reflect what you've defined in the one config file. So I don't have to learn much, and I don't really want to learn much around sysadmin. I'd rather just build products. This slide just has some code in it, as you can see. There'll be gradually more and more code as we go along. It's not so important exactly to be able to read this. Like, don't bother taking notes. If you want to go through this, I have a really detailed article on my blog you can look at later. But it is worth saying that installing Nix, the package manager, takes like 30 seconds on my machine with my crappy internet connection at home. You just curl their install script into your shell. Maybe some security people here might cringe at that, but it's the way it's done. And then you do some plumbing and you install some other like Haskell-y tool things, like this Cabal to Nix tool that takes a Haskell Cabal file, and Cabal is like Haskell's project management tool and also dependency management tool. It takes a Cabal file and turns it into a Nix expression. So that's the sort of transition point between the Haskell world and the Nix world. Because we're writing Haskell and we're deploying it to NixOS, right? And then I also install like GHC, which is the Glasgow Haskell compiler, because you have to compile your stuff. And the Yesod bin, which just like scaffolds your new site. It's like saying Rails new. You'd say stack new Yesod, whatever, I don't know. And then while you're developing, I don't know how many people have actually tried Haskell development before with Cabal, but there's this well-known thing called Cabal hell, and that's where like different versions of your dependencies don't work together, and then if you make a mistake, your system's in a failed state, and you have to like throw the whole thing out and start from scratch, and it's really, really painful. But NixOS sort of gets rid of that problem because everything's separated, so you can't put your machine in a failed state. And when I work with stuff in Haskell, I will use this Cabal to Nix tool to create a sort of isolated shell environment, because I will do my work in the terminal. I don't know how this works outside of the terminal. Sorry. So that first line creates the environment. The second line puts you into it, so you get this new prompt. And the third line is to do a similar kind of thing, but it makes an application sort of expression for Nix, which you need for deployment later. You don't have to understand what that means. Are there any questions at this point? Or is it fairly clear? It's clear? Yeah. Excellent. Okay. Are there Rails developers here? Who does Rails? You do Rails? One does Rails. One happy person in the room. There's a really good Rails book. I think it's just called the Rails Tutorial by Michael Hartle. You can read it for free online. And what I really like, or one thing that I really like about that book, despite it being free, is that one of the first things you do, rather than building an application, one of the first things you do is deploy the system somewhere. So like straight away, you can share your hello world with your friends. It's really gratifying having a product that you can like use and show to people. I think this is super important, and I think if you develop stuff in isolation, then there's a good chance it'll never be released. It just exists in a vacuum, and then it's good for nothing. So what I suggest you do is straight away use this tool called the NixOps, which is part of the Nix ecosystem. And NixOps, again, is declarative, and basically you tell it how your server infrastructure should look. It's super simple. In my case, I just say, well, I want one EC2 instance on Amazon. And it'll run my web application and Postgres and TarSnap for backups. And NixOps will SSH into Amazon for me. And then if there isn't already a server running, it'll spin one up for me. And then it'll build all my stuff and deploy it for me. So I don't have to be a DevOps guy. I don't have to learn any of that. It's all done for free. It's really nice. But I want to learn this stuff. So getting that going is as simple as installing NixOps with the Nix environment tool, then either creating a new deployment or modifying an existing one. And again, you don't have to write this down. You can read it later. And then you deploy it with one command. And if you want to SSH into the server, there's also a convenience method for SSHing into the server to manually play with stuff. So pretty quickly, within 20 minutes, you have a working application on Amazon. Now we'll just look at some Jezen code. And the really nice thing about Jezen is that you don't need to be a Haskeller to understand it. And as I said, like, I have no idea what I'm doing. I'm not a Haskell expert, but still I make software that I'm confident in with this framework, because it abstracts a lot of the tedious stuff away from me. Jezen gives you type-safe routing. So if you make a mistake typing out some route in your application, it'll tell you straight away at compile time. You won't have this issue where you'll have a broken route in production, and then a user will find it and then call you or email you and say, hey, it's broken. Because it tells you straight away. So the machine sort of, it knows where all the problems are, and it tells you. And this is super easy to understand. You have like the path, and then you give that route a name, and then you specify what HTTP methods it responds to. Like, that's so easy to read for me. One interesting thing is on that last line, you can see I have this thing, and thing might represent some model, something in my system, maybe a user or a post. And the bit after that, where it says sort of octothorpe or hash UUID, I'm specifying the type of the parameter that goes in. So if someone passes in a parameter that doesn't match the type, it's going to send a 404 back straight away at the router. So it's not going to, like, if someone goes to thing/4, that's not a UUID. So it's not going to like go to the database layer and say, oh, there's nothing in the database that matches that. It's just going to say 404 straight away, which really helps with performance as well. In Rails, I thought there'd be more Rails developers here, that's why I keep using Rails. But in Rails, you define your database schema with migrations, and I think you've all worked with migrations. It's this imperative thing where you write like a step, like do this, and that'll be applied to the database to give you some structure. And if you want to like alter something or take some fields down, you have to write more steps to undo the previous work. In Jezen, you don't do that. You just say what your data looks like. And in this case, again, it's very easy to read because this is just like a domain-specific language. It doesn't look like Haskell, but it is. It's actually template Haskell, which is like a Lisp macro, or it's code generation. And here we're just saying we have a user, and this user has a name, which is like a text field. They have an email, which is more text. They have an identity, which is an OAuth thing. We have a field to say when they were created, and that's a timestamp. And we have a unique constraint on their email address. And it's a similar story with this email proxy model that I have in one of my applications. So you would write this, and then the framework comes up with the migrations necessary to make your database reflect this file. So you don't have to do any migrations. This is your single point of truth, which makes it I won't say easier to reason about. I won't say easier to reason about. Makes it easier to think about. Okay, so in Yesod, you have what's called a handler, and this is analogous to any other application's controller. I guess in the code it's a bit hard to read. Is it? Maybe I can zoom in, I think. So those first two lines, you can kind of ignore them. Is that jumbo-sized enough? Is that good? So this line, if you're not familiar with Haskell, and I'm not expecting you to be, all that says is this handler responds to the GET requests that we specified in the router, the routes file. So it's the get home route or resource, and its return type is some HTML wrapped in a handler. So that's just a type signature, doesn't do anything other than specify inputs and outputs. And the next bit is actually what the function does. And you'll notice that word do. This is monadic do syntax in Haskell, but you don't need to know what monads are or how they work or anything like that to understand what do means. Like, do this, and then that, and then that. That's all it is. Just do these steps. So it's still imperative programming. People say you can't do imperative programming in Haskell. It's not true. Do these things. The next line. This is really simple. MUID, that's a really terrible name, and if you go to most software conferences, they'll not let you use names like that. The ID part, I think you know what an ID is. Before that, there's a U. In my case, that's user. And before that, M for maybe. And that, this is just a name that I use, right? The maybe signifies that maybe we'll get an ID and maybe we won't. So we're being really, really explicit about, like, this could be nil. In Ruby, you have nils. You don't always have to handle them. And if you call a method on a nil, it explodes. You can't really do that in Haskell. You have to be really explicit about what data might or might not be there. So the arrow just means we're deriving the value on the left from the result of this expression on the right. So maybe auth ID tries to find a logged in user, like a session, and whatever the result is, stuffs it in a thing on the left. And then we handle both the cases of what that could be. So there's always going to be something in maybe user ID or MUID, and it's either going to be nothing, and then we handle the case that when there's nothing in there, or it's just something. That underscore after the just, it means like we don't care what the value is. As long as there's something there, then we know we have a logged in user. And we're just saying, like, if there's nothing, then the user's not authenticated, so we just render the home page. And if we have a user, let's redirect them to one of the authenticated pages. So that's authentication handled, really simple. I should explain, I should give some context. I recently wrote a very small web application that's just sort of a backend for contact forms for static websites. Who here has a static website, like a static site with this generator? Yeah? So you know that you can't have a contact form because you can't send it anywhere. So I built this service where I give you an endpoint, and when you submit the form, either with a normal submission or like an AJAX request, my system takes the data and then emails it to you, and it's simple, right? So this is what a form would look like in Yesod. Again, you can forget the stuff at the top, it's not really important. If we just look at the type signature of this function, it basically says email proxy form takes a user ID, and it also takes some text, and it returns email proxy wrapped in a form. So if this function's ever called without those two parameters that it needs, the user ID and the text, the compiler's going to tell you straight away. So you can't have these problems in your system with like connaissance of name or connaissance of like positional parameters, which is what I have a lot in Ruby on Rails or any language like that, is that you have objects and they message each other, and you have to write so many tests that make sure that you're talking to objects with the right arguments and that things are receiving the right arguments. You don't have that in Haskell, so you don't have to write so many tests. So this function, you don't have to understand what it says. It basically just says, it renders some fields for our form, a URL field, an email field, and then some other monadic stuff, like it gets the current time, and it gets a random sort of UUID, which is the endpoint I give back to the user, and also the user ID. And these fields correspond with the email proxy model that I wrote in the models file. So every field that was there, it's also here, because we're updating that record. And at the start over here, where it says a rec, A just means applicative, but you don't need to know what that means. And rec is short for required. So it'll say it's a required field. And if the value is not there, then it's a validation error. And URL field means it has to be a URL, otherwise it's invalid. Email field, same story. And it's not, you don't have to be a Haskell to understand what those mean, I think. This is the last example I have. As it got more and more technical as we went on. This is almost the same as a couple of slides ago, but here we're saying user ID because we're requiring an auth ID. If we don't get one, then the framework knows to just like send them back to the login screen. And then here, whoops, don't do stuff. No, don't find that. M user is for maybe user because, well, okay, we know the users in the system if they can be authenticated. I haven't figured out how to get around that bit yet. But we're using Yesod's database persistence, like ORM thing. It's called persistent for this get function. And that's really interesting as well because we're not saying like get a user at this ID. We're just saying get this user ID. Like it knows to get the record from the users table because the value that comes from require auth ID, it knows that's a user. It's type safe as well. You're not going to accidentally get something from the blog posts label and put it in a user. It doesn't work that way. The next couple of lines is I'm just pulling out an email proxy. Like, yeah, it's not so interesting, I think. And then here's an example of like running the form. We have that email proxy form that I defined in the previous slide, and I'm passing in the user ID and then the user's email address. And this from just function, if you do Haskell, don't ever use that. Like that's bad. That from just assumes that there will always be a user. And in this case, there is always a user, but the way Haskell is designed, you have to account for the case when there isn't one. And I've said, well, there always is one. And I'm using from just in another part of my system, and as soon as there isn't a record there or a value there, it throws an exception, so the user gets a 500 error. Most of the other stuff we've already covered, so that's all I have, and thanks for listening to me. That's it.
To Out of curiosity, is it faster than Rails? Just
Did you miss the performance bit?
I wasn't very focused.
Oh, okay. So from memory, the numbers were like, for Rails, 2,500 requests per second served on an EC2 machine. And on the same EC2 machine, Haskell will do 81,000 requests per second. A little bit faster.
So basically you define some templates in your Haskell that transform to HTML?
Yes, there's a whole sort of HTML abstraction that comes with the framework as well. But it's so similar to HTML that you'd normally use in any language, it's not worth covering in a talk, I think. But you get all that conventional framework stuff there as well. One really nice thing about Jezen is that it has this concept of widgets, which is really popular in the JavaScript world right now. In JavaScript, you have like a React component, and you define all the markup and all the styles in the components, so everything's together. But Jezen's had this for like at least 5 years, I think, since the beginning. You have a widget with all your markup, and you have your styles, which is separate. But if the user didn't use that, then it's not compiled.
And so you use this in production, right?
Yes. So I just released an application this week called asimpleform.com. I was talking about it just before. It's a backend for static sites. So if you have a static website, it's my first advertising bit. If you have a static website and you need a contact form on it, then just send it to me. It's free. Asimpleform.com. You sign in with GitHub. I give you an endpoint. Your form posts to my endpoint, and it's emailed back to you. Simple.
Cool. Yeah, I looked to something similar in F#, but I considered that over abstraction.
It's too much? It's sort of like killing a mosquito with a cannon?
Yeah.
What else do you do with your time, man?
I have a question.
Sure.
I saw a slide where you showed the deployment process, and I'm curious, what does it do underneath? I mean, does it deploy source and then KBL run, or does it build binary and copy binary? First question, and second question, I'll take chance while I have the microphone.
Sure.
Second question is about monitoring the process. What happens? What happens when the process dies? Will it be restarted? Or how? I mean, the process.
Right. Not out of the box, not automatically. Doesn't have this thing like Erlang where processes respawn straight away. But you can use any other tool for automatically respawning processes that way. I think Systemd does that.
And first question.
With your first question, yeah, perhaps I should have explained NixOps a bit more. So NixOps knows what the architecture of your system is, and it knows what the architecture of the system you're deploying to is. And in my case, you can see I'm using a Mac, and I'm deploying to a Linux machine on Amazon EC2. And because I would compile Haskell on a Mac, I can't run it on Linux. It wouldn't work. So NixOps, if I were to compile on my Mac, what it would do, NixOps would actually take all the source code, upload that to the deployment target, and then build it there. I don't recommend you do that though, because it takes a very, very long time. Because all the source and all the dependencies, that's a lot of stuff to upload. And then the system you're deploying to will run more slowly while it's compiling the system that's going to be deployed. What I do instead, if you have a Linux machine, then I guess it doesn't matter. But I use Mac, so what I do instead is I have a virtual machine, like a Vagrant box, and I just I compile and deploy from there. So it compiles on my machine, and then just the executable is sent to Amazon, to the EC2 instance. If something breaks, as I said before, NixOps and the whole Nix idea, they don't overwrite packages. So if something breaks, it's one command to roll back that deployment. And rollbacks happen instantly because it doesn't like change files or move things around. It just changes symbolic links, and that's really, really fast, right? So it just updates a bunch of symbolic links to point to the previous working deployment.
Thank you.
No problem. More questions. Excellent.
I'm sorry, but I would like to ask about a question regarding databases. So you designed a model of 2 tables inside of your data,
Yep.
and migration happens automatically, something similar like packaged language for any domain model, like it automatically add fields, remove fields, and all that.
That's
stuff.
right.
So how would you do migration? Of, for example, if it's not just simple adding of something, but when you need to convert some data from one to another or something like that, so would you need to run some additional tools between of that? It should be part of that Nix ops scripts or something like that. Okay.
Does that answer the question? I should say actually, Yesod, while it does migrations for you, it'll never do a destructive migration. It'll just say, this migration you want to do could potentially lose data, so we're not doing it for you. You can do it manually. That's their take on it. Yeah.
Thank you for the talk. I'm curious how far could you get without actually understanding all the monadic stuff going on in your samples? Could you treat it like, I don't know, some kind of special DSL or special syntax for building your application, or you wouldn't move forward much further than a simple hello world application without actually understanding how the things works, because actually the samples are quite simple from structural view, but there are some very high-level abstractions involved. What's your experience?
I haven't had to build anything super complicated yet. I build web applications for like software as a service type things, and I think I haven't had to like build anything outside that realm at this point, so I don't know. I think if you're building something complicated like a computer game, then you'd have to. But in my case, just working with software as a service type applications, no, I don't understand a lot of the stuff, and it works. And what's really nice about it is that in the Rails world, in the Ruby world, you have to read a whole lot of documentation, and you just pray that it's there. And you just expect the stuff to work the same way as is documented. In Haskell, my experience has been that there's not so much documentation, but there's a whole lot of code, and the code says exactly what it does. It can't say one thing and do another. It doesn't work that way, so it wouldn't compile. So it's very easy to read the code in Haskell. And it's very hard to make obvious mistakes because the compiler would tell you about it. So I got pretty far without learning complicated stuff.
Okay, great, thank you.
No problem. Another one?
I hope this one will be better. So initially you were saying that one cannot write tests because one doesn't know what he doesn't know. That was...
Yes.
And then with strongly typing and with Haskell that enforce you to actually declare all the cases, isn't that actually making, like, not writing the test, but actually thinking about the test? I mean, isn't the development speed like kind of the same? You just don't write so much text, but you have to think the mental model should be kind of the same, right?
Initially, yes. And for me right now, because I'm not as fluent in Haskell as I am in, say, Ruby, it's slower for me. But how does that translate over the long term? I mean, as a Ruby on Rails project would gradually get more complicated, you have to start thinking about more things, like how does this relate to that? How does this change affect the other thing? And it gets harder and harder, whereas with Haskell, I don't think it gets harder because everything is kept in check by the compiler. And that's not something specific to the framework. That's just about using a much smarter tool, as in Haskell as a language, as opposed to like a interpreted dynamic language. I'm not sure if I answered the question.
No, I was expecting that at one point you'll just get the program that cannot be compiled because your mental model doesn't match the what the program can do. For example,
sure,
when
yeah.
it's like on the rail side, it's covered by the test, and one moment you
but it's only
if you wrote them, of course.
Yeah, it's a test that you wrote. So you understand the tests that you wrote, and you can account for those edge cases and those potential problems, but you can't account for the tests that you didn't write. Because you can write a few tests and not write all of them, and your tests pass, and your production software is still broken, because you didn't think to write the right number of tests for that function. Does that make sense?
Yes, it just I'm not experienced with Haskell, and I was wondering, like, at one point, if one will get to the point that just program cannot be compiled or something like this.
Well, yeah, if it can't be compiled, then you know that you've got a serious problem. You have to review. Whereas with any sort of dynamic language, it wouldn't tell you anything. It would just say, yeah, I'll run it, no problem.
That's legit. Yeah.
As a sort of corollary to that, Haskell made popular this thing called quick check. I see some nodding heads so people know what it is, but for those that don't know what quick check is, if you do isolated tests, usually you send some stuff into a function and test that the right stuff comes out. But you have to be really rigorous and like test it with lots of different kind of things going in. What quick check does is it just like spams your function with loads of different things. So you can be really rigorous and make sure that you've tested all the cases. And that comes for free with Haskell. And there are lots of implementations in other languages. So whatever language you use, there's probably a quick check for it. So check that out too.
Thank you.
Thank you.
I wanted just a quick question. What applications have you built with this framework? You actually mentioned your static page application, but have you built bigger applications like bigger websites or, well, not the database abstractions? Well,
I haven't built anything much bigger than that.
Oh.
Nor do I really want to be honest. Like, I have a day job and I like cars, I go driving. So this kind of ties into why I chose Haskell in the first place, because I don't really enjoy maintaining software. I'd like it to work, and then I want to go to the beach.
Oh, nice.
So, yeah.
So you're lazy, you're good. That's a good feature.
Thank you.
I'm sorry, last question.
Don't apologize, this is great.
I have a question regarding authentication and basically the backend. So I guess the backend is pure Haskell code, so you don't have actual web server. It serves as handlers inside of that. Is that correct?
There's a server that Jezen runs on called Warp. I don't get my hands dirty with it, so I just I let the framework take care of it.
So yeah, so question about authentication means what types of authentication you know that it might be supported and what you actually implemented. I saw that there is a code, but we didn't see actual code behind of that. So is it sessions, is it cookies, is it some digests?
In the application that I was talking about, my asimpleform.com, I don't really want to handle people's passwords for this, and I want it to be really, really quick and simple for people to get going. So I'm just using OAuth. So you log in with your GitHub account. And there are libraries for Google, for Spotify, for a bunch of other things, OAuth things. And another application that I wrote is just a traditional sort of email and password. There are a couple of other things, but I'm not really interested in the other things. Like email and password is enough, or OAuth is enough for me. So.
And a last question regarding like SSL. So I guess that script is just simple copy of webend, and that web server which you mentioned, WOP, that handles SSL, and you can like deploy that with that Nix ops.
Yep.
Script. Yeah. Okay. Thank you.
Basically, in my case, I don't have to do any SSL specific stuff in the application, and I just deploy it to my server, and then I stick the whole thing behind Cloudflare, and they give you SSL for free. So. Again, I don't want to get my hands dirty with too much stuff because I got other things I want to do with my life. The point is, yes, Haskell seems academic and complicated, but actually, no, it's not. It can make your life a whole bunch easier. Just work that a little bit harder to learn it initially, and then you can like relax a bit more in life. I hope I'm selling it well. Was that everything? Anything else? I think that was it. Okay, well, thanks very much.